Hello, my name is Keaton again, and here I am on video 2 of our several parts segments in explaining the system. In this video, I will try to explain the flow mechanics of the water throughout these grow beds, the tanks, and all the components, as well as the water levels and what you should be looking for, and if anything is off, how to troubleshoot. So diving first in, I will start with a flow diagram of the system, similar to what was given in video 1, the overview, but I will start this time a little bit more in depth from the tank. So, coming out of the tank, from this fish tank setup, we have dirty water that is full of ammonia and fish contaminants coming out of this tank through this upfill tube here. The tube is connected at a U-joint, which I try not to squeeze on very tightly. I just connect it very lightly as to not have a challenge unconnecting it. From that U-joint, it comes out over here to this bulkhead fitting that is drilled into the side of the glass, if you can see. So, from that fitting in the back there, that black one, you see it goes down. From that fitting in the back, you see it goes down and over to that this parallel component here. That is the water from the fish tank, and you see it feeds right into this blue barrel or the solids containment settle. Here we could have a filter cloth that would allow all the solid particles to be further broken up and captured before gunking up the grow beds. However, since we did not want turbulence in this blue barrel, we had to make it so that the pump is in this yellow barrel. So you see there's an overflow here from there into this. Also, you can see an overflow out the back. So if for whatever reason this one gets clogged or something happens there, and too much water is coming in here, you can see that there is an overflow out into this black bin. But naturally, the water will drain from this blue filter setup into this yellow bin. In the yellow bin, all we have is a pump at the bottom that shoots water up through that tube and out. Because here we needed more water or less water coming into this than is getting out here. So the pump in this bin is set higher than needed to drain this pump. And that's just so we don't have an overflow of this container and out that back way. However, as stated in the first video, we have a switch that can detect the water levels, and if running properly, would allow this pump to just run when it's exclusively underwater to prolong the longevity of this pump. But going from this yellow container, we have water being pumped here out and up this tube. You can see the tube here in the back. From there, it gets split off at the top, the 3-piece separator, and there we have an open hole to prevent any sort of siphoning. But one of these tubes runs into this top grow bed and discharges right about there. And then the other tube is gravity fed down into this bottom grow bed, and you can see has a continuous discharge. This is important that the discharge is continuous and steady, which means it's enough to initiate the filter or the siphon. So going into a siphon, these grow beds both flood and drain. So you will see they start low, they raise completely, and then they drain all the way. They raise completely and drain. Right there is the discharge for the upper grow bed, and this is the discharge for a lower grow bed. You can see that it's discharging right now. It's on the drain siphon because of how prominent that water flow is. It's really coming out. But when it is flooding, you will see no water coming out of this one or this one. So going in here and explaining the bell siphon, this is the same component as in that upper grow bed there. And here you see in the upper grow bed, it bell siphons, discharges, boom, right into this black box. So this is where our clean water is stored and where the discharge out of the grow beds is. But explaining this bell siphon a little bit more in depth, here we have our inner tube, as shown here. That's our straight discharge. And then we have this cover, or the bell siphon. The bell siphon is able to initiate a siphon and suck up water when the water level is high. So here you will see the water is going to just keep increasing until the siphon is triggered. And then it will create a vacuum within this and start the siphon. This hose here into that Petri dish, which you can see at the bottom, that is an elephant siphon, and that is just there to break the siphon and break the pressure within this cap when the water reaches the level of that Petri dish. So I will let you just see the full process here. Currently, there's very little water coming out of this. It's draining a little bit because it's about to initiate the siphon. And then the siphon will initiate any moment here, and you will see the water level start to decrease. It will be shown here. Okay, water level's going down slightly. Water level's going down slightly. Siphon just kicked in there. So see how fast that water is draining, and look at the discharge from this. There you can see accurately the reflection of that. And now when this hits the bottom, you will see that that Petri dish in the middle completely dries out, stopping the siphon and triggering a disengage just for it to fill up again. So Petri dish is lowering, disengage. That gurgle right there was the disengage of the siphon, and now we are refilling. And because it disengaged, there's no more water coming out of this. But this upstairs is engaged. So that's the same process. Here, there are several mechanisms that might mess with the siphon. There are several issues. A, the siphon will not engage, meaning that the water level is at a high height or at a constant height right about where the tip of my finger is. But it is not enough water to create a pressure void within the bell siphon and initiate a full-on siphon. The problem of that mostly is that it is not feeding enough water. If this flow rate is not significant, it is not a significant enough flow rate to fully initiate this siphon. Another issue is that the water will be stuck at the bottom of the siphon, at the bell, and it will never disengage a siphon. That issue has been troubleshot by us implementing the snorkel elephant siphon there, and adding this Petri dish to allow the siphon to disengage. So going back to potential issues of the water not engaging, that's the primary issue we have. For a temporary fix, you can raise this. If you raise that, I just raise the water stuck in the siphon and I feel a vacuum, and now the siphon is going again. Boom. So that's one way to drain the grow beds. Another way to drain the grow beds is to pull out this pipe completely. I can just wiggle it and pull that out, and then the water level will stay at the base there. And if I take this off, then the water level will stay at the top. There will be no siphon action going on. But overall, the primary issue of the siphon not engaging is that there's not enough flow into the siphon, therefore not enough pressure to engage the siphon. The primary problem with that, there are several primary problems with that I'll walk into. Another potential issue with the bell siphon is if there is too much flow going into these grow beds, then the bell siphon could not trigger fast enough and could lead to a potential leak over the edge. I don't think you will encounter that unless the bell siphon is clogged of some sort. We've had it where these clay grow media have fallen and broken this barrier and clogged the intra bell siphon, and then we've had overflow off the edge of this grow bed. But as long as the bell siphon is clean, you shouldn't run into any of those issues. So what can minimize the amount of discharge water into this grow bed? There are several aspects. First off, you will see that this is not flowing at proper rate. That could be because this pump in here is not working. You feel a little vibration. When I put my hand on it, I feel a vibration telling me the pump is working. Also, because we are getting water inflow, it shows that the pump is working. Another potential reason that could not be getting enough water is because this is not discharging fast enough. One possible way for that to be shown is if the X flow of that is clogged, this will overflow and will not discharge into the blue bin. That is a potential issue. Another potential issue is if the water level in this fish tank is really low. And the lowest it will go is about there, where my finger is. So about 1.5 inches from the bottom of this black lip here. If the water is low in this fish tank, that means that it is not draining enough to this blue bin, and therefore the yellow bin is not pumping enough water into these grow beds, which is what is stopping this bell siphon from initiating. And the reason you can see the water would be so low there is because either this black tank is empty or almost empty, meaning the pump is sucking air, or because this black tank, the pump within this black tank here that shoots water from this tank to here through that pipe you see right there, this pipe here, that pump is not working. If that pump does not work, this will have a low water level and you will not see any inflow of water into this tank via this pole. So those are all of the ways that you can that could be potential problems for the bell siphon not working. And the way you can ID that is based off the water level in the fish tank most of the times. If the water level is too short, the issue that I just described will arise, or if the water level is too high, then we have a potential possibility of this fish tank overflowing. So if the water is too high, you want to take steps to mitigate that. Too high for me is right above the edge here, right here. If it gets higher than that, I'll take a step to mitigate that. And there are two possible steps to reduce that water level. The first step, and the one that I recommend, is manipulating this pipe here, the outflow pipe of the fish tank. You will see that this outflow pipe, it's covered with these gratings. These can just be pulled up. But I pull out the outflow pipe, I pull out that 90 degree, I pull it that way. I pull the 90 degree that way, and then I just pull out this entire bottom pipe. And what you want to do with this is you want to take a hose to that screen there. That screen is made so no fish go into it, but at the same time it catches a lot of gunk. And you just want to hose off that gunk and clean out the tank. Because if that outflow pipe is not taking the full capacity of water, then it will result in a much higher water level. Currently, the pipe dimensions, I believe, are 1 1/4, meaning that it is able to sustain this much water, but it can't sustain much greater flow than that. So any restriction in the flow of that pipe will lead to the water level in the fish tank rising. Another potential way to manipulate the water level in this fish tank is through the feeder pump. And that is this pump that feeds the fish tank. This pump right here has a dial. This dial can be twisted, I believe, if it's twisted so it is in line with my finger. If it's twisted that way, it will lead to more flow. And if it's twisted to be in line with my finger now, it'll lead to less flow. Another potential issue with this pump is that it gets clogged or so by, a dirt or a leaf litter, and that will also restrict the flow. But you can manipulate this and shut it a little bit more if the water level is too high. But the first step to doing that is cleaning this outflow pipe to decrease the water level. So following up with some of the hydraulic components of this system, it is important that I lay out the volumes of every component here. So here, this is a rough estimate of the volume. This fish tank itself is 120 gallons, including all the rock and wood. I estimate 110 gallons. The front grow bed is 21.2 gallons of volume of water. That is not including the volume that the solid media takes up. The upper grow bed itself is 23 gallons. The upper grow bed is 23 gallons, again, not including the clay media. This overflow tank is about 63 gallons. So when we add in water, we add in usually around 40 gallons or so. That will be incorporated into the next video, which is upkeep and maintenance. The yellow bin is 20 gallons, and this blue bin is 30 gallons of water, overall leading to a rough average of 270 gallons within the system. All of the components we use are PVC sealed and painted in some place. And as you can see on several of these connectors down here under the bell siphon, they are attached by rubber gaskets that fit on there, allowing all of this PVC to be deassembled and stored along with the system. They are all about 1.5 inches in diameter, with the only exclusion being the outflow of this tank, which is 1 1/4. That is it. Thank you.